Hi, I'm David Goldschlag, co-founder and CEO at Aembit. I'd like to take a few minutes to talk through workload IAM, okay? But first, let's give some context. When I say IAM, you probably are familiar with Okta or Microsoft Azure AD, which helps users log into services, users logging into Microsoft 365 or Salesforce, right, or other services. It does single sign-on, does a login, okay? But we're not concerned here about user login to services. We're concerned here about applications logging into other services. And by applications, we call those workloads, right? And it's pieces of software instead of users accessing services. So it could be that you have some software that's going to a database, okay? Or it could be you have some software that's going to a SaaS app like Salesforce. Or it could be you have some software going to other pieces of software or to some other third-party cloud API. And in these cases, you need to authenticate the workload in order to access the service securely, okay? And that sounds like an identity and access problem, okay? And if you don't authenticate, you're leaving the gates open and then anybody can get to your services. And that's clearly not secure, okay? So this is very common use cases. People are writing their own software. It could be prepackaged software. It could be scripts. It could be anything that's running, that's software that's operating, that's accessing other services. Okay, so how do people do secure access today? Before going on to workload IAM, which would be applying IAM principles to workload to service access, let's talk about how people do secure access between workloads today. And there's basically three approaches, okay? One is using secrets managers, often called vaults as well, okay? And that basically is a database within which you store the secrets or the keys, the API keys, that are used to authenticate the workload, the client workload, to the service, or the username and password that's used for the service account that lets that client workload access that service. If you think about it, secrets managers are a lot like password managers were in the user world before you started to use systems like Okta or Azure AD for single sign-on to applications. So secrets managers are a good place to store the secret easily, but it doesn't solve the life cycle of the secret. How do you get the right credential into the secrets manager, and how do you get it dynamically to the client workload when the client workload needs it, and how do you rotate that credential when you need to change that password over time? So secrets managers solve a problem well, which is where do you store the secret, but it doesn't solve the overall life cycle problem. Just like password managers evolved to IAM over time, you probably want to move from secrets managers to something that cares about the life cycle. It takes care of the life cycle of the credential. Another approach that we're seeing is kind of do it yourself, okay? People may have a secrets manager and they may add on some capabilities to put secrets or credentials into the secrets manager, and then they may have some capabilities to extend that to dynamically deliver the credentials from the secrets manager to the client applications. But that generally requires a pretty sophisticated organization that's really ready to invest in all of the plumbing that makes the end-to-end life cycle work well. A third approach here is called cloud IAM, and that's closest to what we do, what I'd like to talk about in a more general way. But cloud IAM is provided by the cloud provider, AWS, Azure, or GCP, Google Cloud, offers cloud IAM, and that helps services that run in that cloud, workload that run in that cloud, access native resources in that cloud. So if you're going from an AWS VM to an S3 bucket, you can use Azure, you can use AWS IAM. If you're using GCP and you have a Kubernetes container in GCP that's going to Google BigQuery, you can use GCP IAM in order to do that. But once you need to go between clouds, okay, so you're going from your AWS VM to Salesforce, or you're going from AWS to a resource in GCP, or in fact, within a single cloud, you're going to non-native services, cloud delivered IAM just starts to be less useful. It's less general, okay? But the paradigm is the right one, starting to manage things by policies instead of by managing things through secrets. What you really need is a generalization of the cloud provider IAM that applies more broadly, okay, to kind of an any-to-any story, wherever workloads run, whether they're in a cloud or on-premise, okay, and wherever your services are, whether they're in the same cloud or the third-party services cloud APIs or their partner APIs, you want to be able to manage access from any to any, okay? And the way that this would work is the cloud workload IAM. Workload IAM is a cloud service, and it lives in a control plane. We call that the identity control plane, and it mediates access. And what it does is when your workload wants to access a service, take an example, a client workload going to the Snowflake database, data warehouse. The client workload would authenticate itself to the workload IAM, and the workload IAM would say, oh, is it workload A? And then it would say, is workload A allowed to access Snowflake? And then if it is, it would dynamically issue the credential that lets that workload access Snowflake, okay? And when it issues the credential, it could be a short-lived credential. The credential is issued dynamically. It doesn't have to be a long-lived username and password. It could be a short-lived credential, whatever the workload is supposed to be. But if you notice what's happening here is you move away from the paradigm of managing secrets like you would in a secrets manager to managing policies. You're setting policies here. Workload A is allowed to access Snowflake. And then the IAM system, after checking the policy, automatically manages the credentials for you, and in fact will move you to short-lived credentials where possible. So the advantage here is you're managing access, not secrets. You're managing things at a policy-based layer, okay? You get full audit, okay, to understand who's accessing what, or what's accessing what. Remember, we're talking about workload IAM. And you can do that both for operational analytics and also for security audits, okay? Notice here that this is a control plane architecture, not a data plane architecture. When the workload actually accesses Snowflake or Salesforce or whatever it's trying to access, that happens directly between that workload and that service over your own network or over the internet. The control plane here is only to make the access decision and to deliver the credential. And of course, if the credential is not delivered, the access can't happen, and that's how the security is enforced. Finally, in order to do this easily, okay, we offer the ability to do this with no code changes. So your workloads can be complemented with some of our tooling in order to be able to interact with the Aembit workload IAM service without needing code changes at the workload. And what that means is from a deployment perspective, DevOps can manage workload identities using guardrails given by security without needing to burden the developers with coding up auth themselves. And coding up auth is often complicated, and if you don't do it right, it introduces flaws. And this way, you can move the responsibility for secure access away from developers and make it part of the native plumbing, and let developers then focus on building the business function, and let DevOps enable secure connections by policy that can be audited for the rest of the organization. Thank you very much.